All right. Thank you very much for coming. I am indeed very honored and very excited to hear what I really have to say myself. I want to have a shout out to my 3 kids at home, Benjamin, Franklin, and Emily. Emily is excited because she's only 8 years old, and Daddy promised that I'll show her artwork, and of course my wife's artwork as well. As you can see, I changed my title a little bit because I felt that this will fit the theme of what I will present a lot better, because I wanted to show you how it took me some 31 to 32 years to study the role of the sun on climate. Sort of showing you parts, all the components that I have to assemble together to reach certain level of understanding. And in fact, I say that the problem is unresolved still yet. And of course, I'm now, since 2018, I created this Center for Environmental Research and Earth Sciences, so I'll explain to you a bit later. And starting this year, I also have affiliation in Hungary, of all places, since places in the United States seem to be very unfriendly to Willie Soon. It's mainly, all these years, the most purest pleasure to be in science is to gain all this friendship and scientists that you can work with. So today, come on, guys. Advance, next. Next. Okay, I want to feature the work from my 2 friends, Victor and Sionso. And these are new results and new tools that we have to create, essentially, to try to understand the climate better. Especially, I want to show also the Ipcc's flaw, in terms of their understanding of CO2 forcing. Let's click the next one so the video will play and the sound will come out. It is a family event. I get my son to do this music for me. Indeed, right? Next. The sun is very big. The earth is small, right? About 110 times smaller. But, of course, it's not the size that determines the role of the sun in this climate system, right? It's actually the energetics. The whole system is completely powered by the sun. Our earth barely have any small amount of radioactive energy, and you can see it's 2 billion times smaller. If you remember the talk from Tom Sheehan, he actually showed the results from Professor Harper's work that quantify the CO2 molecule is emitting something like 10 to the minus 22 watts, right? We're all about numbers, so sorry. Yeah, indeed, there's not much sources of energy else to do this. That's why we will have a serious problem if we have an ice age, not because we have global warming, really, if you think about this. And I want to explain that Ipcc indeed is this UN Intergovernmental Panel on Climate Change. They are a political body. They were never ever interested in science in the first place, right? Because you can see this is the stated objective, is to provide governments at all levels with scientific information that they can use to decide climate policy. This is the latest Ipcc report, the one that came out in August, right, early August. It's clearly premature to say that it's unequivocal that human influence has warmed the atmosphere and ocean and land. And I'll explain to you, we will show evidence, of course. This is not all about arm waving, because your hand will be really tired if you follow Ipcc's method. And here's the Ipcc do this. Ipcc would like you to focus only on this graph. Doesn't matter what I'm plotting, what that scale means. CO2 very big, 2.16 watt per meter square. The sun barely got 0. Look at the precision they have, minus 0.06 to plus 0.08. They want you to focus on the climate system without seasonal cycle, without anything else. Just fixed all the seasonal, it's exactly the same every year. Every winter and next winter is exactly the same, and we have never observed that phenomenon on planet Earth, so it's a puzzle. Then I beg you to look at the data this way. You really need to consider, again, as we often say, we use their argument, we use their numbers just to prove that they actually don't know what they're talking about, right? So that's why we assume that they are right for now. You need to consider this baseline and change, because you really have to consider seasonality of the incoming sunlight. Here's one way to look at this, right? I hope that everybody agree that this is a universal agreement. We are being trapped by the sun and we have to go around the system, right? Earth's orbit is elliptical, not circular. We are much closer to the sun in January than July. And then we really know that, Northern Hemisphere, it's actually less sunlight in January than in July. That shows you that this is one way of physically realize the seasonal cycle, how important it is. This is, of course, standing at the location in Scotland. Funny thing is that I didn't look for this place. It's called Willie Soon, and you can observe this phenomenon, right? The seasonal cycle, no doubt, dominates the whole system. And you cannot ignore it. Here's another way to look for it. I really tried to look for CO2 for a very long time, by the way. You look at the sun's number. This is actually showing you the irradiance from January to December. And 150 years of addition of CO2 can add you this much, right? The pattern just don't fit. And they still insist that this CO2 can govern and control everything, right? Here's another way to look at this. At the top you have the sun and the SST, the incoming sunlight at one particular location, about 32 degrees north. It's all about studying how the nonlinear interaction between the sunlight and the sea surface temperature respond, really. You look at any of the CO2 on a seasonal level, game is off for Ipcc. This is why they never want to talk about all this seasonal thing. The fundamental problem in weather and climate prediction is actually seasonal prediction. They have never solved this problem, no matter how much computer power they do. That's just why I want to tell you why I work so hard to examine this issue. And here's one of the things that we work so hard. I have to revisit Newton's law. Everybody say it's so simple. Just integrate the orbits. So we have to work on this. Yonso is one of the premier scientists on orbital dynamics. So I'm very lucky to be able to get him to try to do this calculation, and we get started since about 2015 or so. We already have a prior before this result that we just produced. This result really supersedes all the previous calculation, because previous calculation that was generated by Professor André Berger of Belgium was last published in 1978 based on some very serious assumption that no one ever looked into it. This is the problem in science. You have to check the assumption. It has the Earth and the moon system is treated as a single unit. The moon is not there, so I'm sorry. You cannot find tides. You cannot find anything in this way of studying. And you look at this result of the summer integration at the sunlight at 65 degrees north in midsummer, right? You can see that it does change, and the impact is quite large. You can see phenomenon like spolar minimum and Maunder minimum of the solar activity cycle. And, this really hint the little ice age issue, right? It's around that kind of period. And then even we can project forward because you're doing orbital calculation, isn't it? And then here's another way to close in to look at the 65 degree summer season. And then indeed, in 65 degree north in the winter, you got nothing, right? Isn't it? So that tells you the race seasonality is so important. The winter season is more related to the heat flux going from equator to the pole region, right? So there are different dynamics involved here. The whole secret of climate science, in my humble opinion, is to figure out this thing. I actually promised my daughter that I won't dance, but I didn't promise her that I won't sing. I realized that if I tell you that I had write all this paper and ask you to read them, I better summarize it with what you call chairman of the board of Las Vegas. Fly me to the moon and let me play among the stars, and let me see the house spring like Jupiter's and Mars. Something like that, right? This is the kind of work that we have to do. So much details that we have to struggle through, and I have to revisit a lot of problems that you think you know, but we actually don't know squat. And we actually have done this. So I want to mention something about Ipcc next. Indeed, blind belief in authority is the greatest enemy of truth. And by the way, this is a sketch that done by my wife during her undergraduate study. You can see that October 5th, they surprise everyone that they get Nobel Prize to these scientists. They're good scientists, no doubt about this. Suki Manabe from Princeton and Klaus Hasselmann from Hamburg. And you can hear from Ross McGittrick. I mean, there's something to challenge even Klaus Hasselmann's work. I would not mention about Parisi, but they got it because they say that the model is actually reliably predicting global warming. And then Ipcc issue a press release for the Nobel Prize in Physics. Actually, I asked the question, what does the Nobel Prize in Physics have to do with Ipcc, right? They want credit. This is really a political phenomenon. Let not be fooled by that. And indeed, they even go as far as they say that it's unavoidable because you know why? The climate model is so good, that it's so accurate that they have to give them Nobel Prize. Okay, or else you all be shot, somehow. It's ridiculous. But how accurate are the climate model? Look no further, you take their word for it. This is Professor Gavin Schmidt of the NASA and also associated with Columbia University, who actually say that the latest generation of CMIC 6 climate model result that you have seen presented by Dave Legates and Pat Michaels, that say that really a lot of these results give implausible result and running a bit too hot, right? And you ended up with numbers or for near terms that are insanely scary or wrong, right? So, hey, it's Gavin Schmidt saying it, not me. So indeed, it's about us, follow the sign, right? This is what follow the signs mean by Ipcc. They are being chained by politics and money and all that, so on and so forth, prestige and so on and so forth. And prestige, believe me, doesn't mean anything in science. It's a very confusing thing for young people, but then we are old enough to understand a lot of this. This is why one of my scientific heroes, beside Professor Harper, is his colleague at Princeton University. He really said that the puzzle, the central mystery of climate science, it really, really has nothing to do with science. It's a human mystery. How does it happen, right? The whole generation of scientific experts are very, very blind to the obvious fact, like seasonal cycle. They just keep saying that it's all done, but it's not done. Anyway, let's look at climate model. How good are they, right? You look at this latest result from CMIT 6. Is to try to quantify the warmest 30% of the sea surface temperature in the tropics, okay, 20 degrees north to 20 degrees south, and then see how the model produced the warm region. Those are the region that about 28 or 27 degrees Celsius to higher. You look at all of it, 534 of this run out of I think some 58 models. Every single one of them got it wrong. I mean, let's not ask for much. Can you do something and show me what you got, right? They got nothing. It's all empty bluffing. And then with sea ice sensitivity to temperature, it's the same. All of the models, some 30 models are collected here from CMIP 6, all fail. And then some of us are a bit lucky, like myself and Ronan Connolly, my colleagues. Connolly et al. 2019, we wrote this paper on the snow cover over Northern Hemisphere. We got cited by Ipcc, we're lucky, right? But this is one of the standard technique. This is really all strategy for them. They try to absorb us so that we'll keep shut up and don't say nothing, right? And they actually try to present it as if that we agree with them that the snow cover is in the Northern Hemisphere and for spring is decreasing. And they are showing that little graph, right? So Connolly et al. 2019 is our paper that we published. And ask them, why do they only show Northern Hemisphere snow cover for the month of April? Oh, here's the answer. They got it wrong for every single season. Please remember, okay, they think that, okay, first of all, you look at winter and fall season. The observations show kind of, increasing, more snow cover in the Northern Hemisphere. And then model always says strictly decreasing. And then even for the spring and summer, it looks like, wow, they're showing decreasing trend. But look at the number, it doesn't fit, okay? You cannot keep claiming that you got all this stuff for the right reason. That's part of the problem with climate model. They always got, even sometimes the result correct, but for the wrong reason. That's no good. I throw that away because I won't use it. It's very dangerous. And indeed, someone mentioned that we produced this paper that came out in around end of July, so before the Ipcc report that came out on August 6th. So this paper involved, basically Ronan Connolly, Michael Connolly, and myself started the whole project. I got invited by a famous academician from China, the premier #1 solar physicist, who asked me to contribute a paper. So I decided to answer this question by writing this very, very comprehensive review that involves some 23 co-authors from 14 countries. The paper cited about 530 references, right? It's really telling you that how complex the subject. We ask a very simple question. how much has the sun influenced the northern hemisphere temperature, right? And we really consider this as an ongoing debate. The story never closed in that sense. And then you can see, when the paper like this came out, one of the clever journalists go and ask Professor Gavin Schmidt from NASA Goddard Institute for Space Study and what he thinks of this paper. Remember, he's a public servant. We are paying for his paycheck, right? He said, this is total nonsense that no one sensible should waste any time on it. Okay? Well, good for him. Thank you, Gavin. Anyway, here's an Ipcc perspective, right? Please read this paper. This is part of the results that we can show in the paper. The top panel showing you the Ipcc anthropogenic global warming universe. The top panel really showing you the observed temperature record that included the urban and the rural station. And then we show you that we can model this quite perfectly, actually. Except the question is, should we use that temperature record, isn't it? And remember, when we say we do this, we actually agree with every single one of the, we can create this result ourselves, but we include the urban station data. This is why Anthony Watts, earlier today, asked the question, why don't we just throw away those contaminated urban stations, right? And can you believe that after some 30-some years, and no one actually even attempted to say, why don't we throw away and just consider the rural station? Don't you think we should take that step? We actually have done that in 2015, so we repeat it again now, which is the top curve there. It's completely different looking. I'm not claiming also this is absolutely correct, but all I know is that when I did this, it's very different output, and we know how to model this with the sun irradiance, okay? It's quite impressive fit. It's not all 100% explained, the variance, but it's up to 90%, okay? This is what I mean by there's another view on this. And we are very confident that this is a very robust result. So you consider the two. I really don't think that we should use the record that Ipcc are in favor. By the way, this is a process in science that we call it still manning. We don't want to do any straw manning kind of thing. You know, we want to make sure that we give Ipcc the highest percentage of benefit or doubt, and I don't agree with that result. I wouldn't use that temperature curve to study climate change. So again, please read this comprehensive paper, because they are trying to censor, but they got really mad. You know why? In a science paper that is 68 pages long with so many references, it's downloaded by now 20,000 times. I mean, that's pretty serious. It's clearly the most downloaded paper now in the journal, right? So next, I'm going to talk about my sunspot work. Again, it takes really a lot of work to try to understand how the sun does things. So I've been trying to learn about sunspot for 32 years. I have written 0 paper. Until this year, everything clicked together. We found a way to try to do this in the right way, called machine learning. It's some artificial intelligence idea. So we actually go forward and try to predict climate model. But before I show any prediction, I want to remind you of this very famous quote of Professor Andre Monin, right, who actually wrote a book called Meteorological Forecasting as a Problem in Physics. It's an MIT Press book, tiny little book, but very readable, 1972. He said that the greatest attention should be devoted to the question whether there is a connection between the Earth weather and the fluctuation in solar activity. The presence of such a connection would be almost a tragedy for meteorology because, right, you really have to necessarily to predict solar activity in order to predict the weather. So I follow that step to see what I can learn about prediction of solar activity. Again, predicting future, we should really learn from wisdom like this. It's a Danish proverb people attributed to Niels Bohr. I don't believe that's correct. It's very difficult to make prediction, especially about the future, isn't it? But I propose today, give me some benefit or doubt, we just give it a try, right? As long as we are very modest about our assumption and what we do. So what is machine learning? The first thing I would say is that let's use art as an illustrative example. Many painters indeed trying to capture fundamental essence of a scene, right? But painting are more than a photograph. So imagine how would Van Gogh would do this drawing of Eiffel Tower. This is one of the things that he would do if you follow his style. You teach the machine to look at the starry night pictures and then learn about the pattern, and therefore it will paint a picture like this, right? And indeed, you can apply that principle to many, many, many painters like William Turner's, you know, you can do it to Edvard Munch, you know, Kandinsky, Pablo Picasso, things like that. So we started to use machine learning. This is among new stuff, it's a hot new wave. I don't believe in all this fashion stuff, by the way. But it is a very powerful tool. So I told my colleague Victor. Victor is a very good mathematician. He's a theoretical physicist, by the way. And so we decided to try this method, right? It's the same thing. The machine learning is trying to capture the essence of the underlying patterns and information in the data sets. So maybe future artists of the future will be computers, but I'll show you that later. Here's an attempt of machine learning trying to paint a picture of the sun using Van Gogh technique. So quickly overview of this result of the first paper that we published. So we decided to use this technique and to study sunspot activity cycle, right? So we asked the algorithm to extrapolate forward and then also backward in time. So forecasting and hindcasting problem. And we are indeed very surprised how good these results are, actually. That's why we decided to publish them, right? And then the algorithm have identified some missing sunspot that was supposed to be there, but it was not there. I mean, it's not. So the machine said that there should be more sunspot than actually the previously counted numbers. That was a very, very powerful way, and then convinced me that we should actually do something in forward forecasting too. And here, first of all, let's show this evidence of our hindcasting. This is for cycle 22 to 23 to 24. So it's from my eye can see 95 to about 2016, 2018 or so, right? The blue and red curve are our model, the black curve are our observation. So I think that we're doing reasonably well. That's how you're confident in reconstructing the solar cycle, right? The activity cycle. These are all the full reconstruction. And indeed that we show that in the future, since about 2008 or so, we are already into some kind of a minimum, sunspot activity minimum, and it will last till about 2050. Okay, this is our formal prediction. And I would like to propose that we call this a Hoyt minimum. Douglas Hoyt is a very brilliant sunspot scholar of all time, I would say. And recently there's a lot of politics, even in sunspot activity, so it's very depressing, by the way. And when those guys are trying to change the sunspot activity record they started since about 20 years now, and then they never even invited Douglas Hoyt for an input. So Douglas Hoyt is this person. He's really, really very good, humble scientist, and he worked extremely hard and very, very able mind. And so this is a pleasure that I was able to collaborate with him now on the next paper, which I will explain. But on the missing sunspot, it's very clear that if you ask, of all the available sunspot, of all the days of every year, how often are we observing the sunspot record? I mean, sunspot activity on the sun. Clearly that since 1800 is very well observed. Even Maunder minimum period from 1645 to 1715 are better observed than 1730 to 1760. This is why the result is interesting. We produce the result first, and then I go look into this data, this statistic which I previously didn't know. It was produced, this kind of result is mainly produced by Douglas Hoyt, obviously. So it's very interesting. And sunspot 25 is here, cycle 25. And I want to show you how our model is performing now, right? So this is our results. The blue curve is our machine learning results. And then the shaded area, obviously, is the uncertainty areas. And then the data is updated to September 2021. And of course, we are not the only player in this game. People love to predict. I hate to predicting, by the way. I really are very reluctant. That's why it took me some 31 years to produce one paper on sunspot activity cycle. This is the first paper. And by the way, this paper, we got Dave Legates to help us also. And if you consider other prediction, you can look. A lot of people keep asking me about Valentina Zakopa's work. This is her result. I won't say anymore, but it's up to you to think what it is. What is the prediction? And then Scott McIntosh is the director of the High Altitude Observatory in Boulder, Colorado. They are the premier area to study sunspot activity cycle. He predicts extremely high sunspot activity cycle. I really believe by now his data were not proven to be true. And then there are other predictions from NASA Ames, Krista Wishley, the lady from NASA Ames. And I believe, and the NOAA consensus result is there. But at least we are in the ballgame. Let's see, right? Because still, no one knows. Because there's no theoretical formulation of the sun to be able to do this right. So here's Emily's, the artist of the future, which I hope that will have a better mind than the computer artificial intelligence, isn't it? Anyway, the second part now, I will finish up very soon, is to study sunspot groups. Okay, what is a sunspot group? What's the sunspot number? So counting sunspot number is surprisingly is a very subjective thing, right? As you know, when it's zero, it's zero. What does it mean? We don't even know, right? That's the kind of thing. And but Douglas Hoy in 1990s, early 90s, decided to say that why don't we study the large region of this sunspot, that formation is called sunspot group, because it's arguably more objective to measure what you call the large-scale magnetic fields behavior that maybe is more connected to things like the solar irradiance as a proxy, right? So we go about and study this. This is an example of how large the size of a sunspot group is. Size of the Earth is there. As you can imagine, this thing will fill about few Earth, right? This size of this. But one of the biggest one is this one. That has the size of a Jupiter. That's about 11 times the size of the Earth. So sunspot group, indeed, we want to count only the sunspot group and see what those records are. So this is our reconstruction, by the way. And this record, we can go back to almost Galileo time. So we can go back and then, again, don't get excited about this graph. It's just a technical graph that's showing you our result is real, and we're publishing this paper. And the top panel just show you the reconstructed sunspot group number from 1610 to 2020. The red patches simply show you that they're a very strong region of a periodic signal, and mainly, of course, it's the 11-year solar cycles. And then there are other peaks at longer times here, like 60 to 120 years. And this is the summary plot to try to show you that indeed there were 3 circular minima and then the long circular maximum of the 20th century, because there is a movement now. The reason why they want to change the sunspot activity record is because they do not like that the sun could possibly explain. So there's a lot of politics involved, mainly the guy like Leif Sausgaard and all that. They are very obsessed with this climate, no global warming by the sun at all. Only the CO2 can do it, which is a very strange proposition. Why don't study it? I'm not making any strong conclusion myself. If I'm proven wrong, so what, right? I'm going home, take a sleep, that's it. I'm a bit tired, so take a sleep. But this is the kind of thing that I really want to say, that we should stop politicizing science, okay? And one of the power of this technique is that, look, we can deduce now the characteristic of the Maunder minimum. Maunder minimum is a period where apparently there's no sunspot appearing, right? But we show that there are some low amount of amplitude sunspot by this algorithm. And indeed, we show that the sunspot activity cycle never ceases. It's still there, which means the solar dynamo is still functioning. This is actually one of the great solar physicists by the name of Edward Walter Maunder, right? I wrote a book on behalf of him and his wife, by the way. In 1922, he already speculated that the sunspot activity probably didn't die in that 70 years. So he predicted there are some peaks around that period. So the time he predicted was all here. And you can see our result doesn't come that far from him, which is quite impressive. And then if you consider other work like from cosmogenic beryllium-10, which is also a proxy for solar activity, I mean, the number is not even close, almost there. Okay, that's it. I'm going to talk about sun-like star, but it will be too short. This is my area of specialties. I spent some 30 years now to study this thing. So our idea is that instead of studying the sun for 400 years, why don't we observe 100 stars, right? Or thousands of stars. This is the kind of project. And indeed, you ask the question, do we have evidence for Maunder minimum activity kind of a behavior to have cyclic cycle? There is new paper that shows things like this. These are based on our work. This is my most cited paper, which is cited almost like 2,000 times, published with Sally by Lunas, my dear colleagues. So this paper indeed shows that there are such thing. Low modulation, some 10-year cycle detected in this sun-like stars. Okay, summary. Since time is close, I'm going to summary. Number 1, the sun is primary driver of the Earth climate. Number 2, the UN Ipcc clearly premature, right, and oversimplified the sun's role and jumped the gun in attributing CO2 as the main culprit for the past and future climate change. Number 3, seasonality of the Earth's orbit is a major factor that has been largely underplayed until now. So I'm going to keep singing to them. By simply choosing different methods of global temperature and solar activity, the sun can explain anything from none to almost all of it, right? Since 1850. Finally, machine learning is a powerful tool, in my humble opinion, for studying the sun